Chakula, this is the sheet you're going to need for the first PowerPoint. The acids, bases, salts, notes. There's not much to fill in, but find that sheet and then we have a very bright red PowerPoint we're going to torture you with. Let's see how we get on here.
If your child ain't all he should be now, this girl could put him right.
So it's one of the few songs I could find with the word acid in it. And we have something called a pH scale, and you've probably heard of pH. And it is a logarithmic scale. That means that it's based on powers of 10. And 7 is neutral pH, and as we go to smaller numbers, the pH becomes more acidic. And as we go to the right, up towards 14, the pH becomes more basic. The word for that also is alkaline. So what we see, let's see if we can get this in here. Strong acids are going to be down in this neck of the woods for pH. Weak acid can be here. Weak base is here. Strong base is there, neutral. And this is at 25 degrees Celsius. So this is how chemists would write it. pH of 7 is neutral, pH less than 7 is acidic, pH of greater than 7 is basic or alkaline. And here's how the slimy English department would do it. So they would have their long-winded approach, blah, 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 blah. But it's much tidier like this at the top. You must memorize properties of acids. So acids taste sour. The word acid is based in Latin for sour. Acids react with active metals. Active metals include things like the alkali metals, the alkaline earth metals, the zinc, and they form conducting solutions. The fancy word for that is electrolytes. And they turn blue litmus red, and see how acid and red almost rhyme. So that's a way of remembering that. So if you bit into a lemon and it tasted sour, it tells you it's acidic. Base properties. Bases taste bitter. They feel slippery. So bases taste bitter, B and B. They feel slippery because bases found in things like soaps will actually eat away at your skin, so you get little ball bearings of skin, makes it slippery. Like acids, they form electrolytes, and instead of blue litmus going red for acids, it's red litmus turns blue. Litmus can be in the form of liquid or paper. We usually use it as a paper, and you'll see that in the lab. When we get to our fourth section of chemistry, one type of reaction is something called a neutralization reaction. Acids and bases neutralize each other. So if you have an acid, you can neutralize it with a base. If you have a base, you can neutralize it with an acid. Way back when in grade 8, you would have seen a video about safety, and it talked about if you have a base spill, you can add vinegar to it. Vinegar is a weak acid. And if you spill acid, you can add sodium bicarbonate, which acts as a weak base. In sports, of course, it's very important to neutralize the best player on the other team. So these are examples of neutralization reactions. Hydrochloric acid plus sodium hydroxide makes sodium chloride plus WOWA. Sulfuric acid plus 2 potassium hydroxides makes potassium sulfate, and 2 waters. So when we say salt, we're talking about an ionic compound. Bases, we got the OH. Acids have the H usually at the front end. We have the Arrhenius definition, and if you go to Chemistry 12, we'll talk about the Arrhenius definition, and then we have some different definitions. For an acid, acids produce hydrogen ions, H plus in solution, so typically they have H at the front end of the formula. Bases produce hydroxide ion, which we know is OH1-. So on the back of the page, we have to tell you, if we look at a formula, we got to be able to figure out if it's an acid, a base, or a salt, or wah-wah. So when we look at the acid here, we see it as, excuse me, H plus at the front end, and it can have any anion, anion's a negative ion, except OH minus. So over here, HCl, H2SO4, and CH3COOH are all acids. Now you're going to say, hey, this is bizarre, the H isn't the front end. This is more what we call an organic acid, and it's customary to show it as COOH, and when we do organic chemistry, we'll get a taste of that. So if you have H at the front end, or if you see COOH, it's an acid. A base will have any cation except H+. Cation just means positive ion, wants to go to cathode. It will have OH at the back porch. So NaOH, KOH, CaOH2 all have the hydroxide ion. They're all bases. Salts will have any positive ion except H+ or cation. And salts will have any anion except OH-. If they had H, it'd make them an acid. If they had OH, it'd make them a base. So these are all examples of ionic compounds that are salts. And of course, if you have H and OH, you end up with HOH, which we say H2O, and that's water. Now, this is coming in again on this slide. You're going to have to find the little piece. That came in very badly. What we're going to do is somewhere on that page, you're going to write down CaSO4, and we're going to practice classifying. I think there's 6 or 8 examples somewhere in there. So I look at CaSO4, and I go like that, boom, boom, boom. I look at the front end, it's not H. I look at the back end, it's not OH. And so I call it a salt. BaOH2, pretty easy to see where the split is because you've got a complex ion. And I have Ba at the front end, not H, but I do have OH at the back end. So that's a base. HgCl2. I'm going to split after the G. This is not H, this is Hg, this is mercury. So this is a salt, no H, no OH. Next one, it's going to split after the Na. There's sodium, and there's C2O4. And we end up with another salt. Next beast, H3PO4. It's going to split after the H. And what we're doing is we're splitting between the positive and negative ion here. We got H at the front end. We don't have OH at the back end. So this is a classic example. Phosphoric acid. Where's our split this time? It's not after the N, it's after the H4. So we have ammonium and we have an OH. Oh, it's got to be a base because we have the OH. No, must have 8 examples here. We got a split after the Li and LiOH. So this must be a base as well. And we see CH3, CH2, COOH. And the split is in a weird place because we see COOH. We got to remember that's an acid. So the negative ion actually comes first and the H plus would be there. And so that is an acid. So that's propanoic acid. Something for Chemistry 11. So that's one of the kind of questions you will see maybe on the odd worksheet and definitely on the practice test, where you have to classify based on the formula. And these rules of thumb that were on the previous slide, I put them in there so you can match up. Oh, I lied. Another example. HBr has to be an acid. That's got to be it. Got to be it. Okay, lied again. HOH. When we say H to the front end, OH to the back end, and we end up with wah-wah. chemists often write water as HOH instead of H2O. There are some reasons for that. We're just about there. Uses. So acids are found in many foods that you're going to eat, lots of fruits. Sulfuric acid is found in car batteries. Hydrochloric acid is in the stomach. Used to be, we teach you about digestive system. Carbonic acid, you have the same acid in your blood as in pop. When you carbonate beverages, you bubble carbon dioxide through it and you make carbonic acid. Bases typically are used for cleaners. They're found in soaps, drain cleaners. So if you have a clogged shower drain and you dump a drain cleaner down there, it's organically going to react with that mess. And you want to have fairly well vented because it's going to stink as it chews its way through the organic material. Oven cleaners, and so we talked about drain cleaners getting the clog. Well, laxatives tend to be bases getting to a different type of clog. Indicators. Indicators are special chemicals that change color according to their pH, and we will look at a chart. And in fact, I think I didn't give it to you, so I will have to post it. And there will be a pH chart that normally you'd be allowed to use on tests and things. They're special chemicals because what they can do is in one form, in the acid form, they'll be one color, and if you put them into a basic situation, they become a different color. And they don't just all change pH around 7, there's total variation. And in Chemistry 12, we look at them in a lot more detail. So we only look at a handful of indicators in the lab that we're going to demonstrate. We have bromethymol blue, phenolphthalein, red litmus, and blue litmus. So bromethymol blue is yellow in acid, it's blue in base, so below 6 it's yellow, above 7.6 is blue, and if we ever get between 6 and 7.6, then we'd have a blend, and blue and yellow make green. In this case, when we're above 10.6, it's a red magenta color, and below 8.2 it's colorless, and you might have used that stuff in grade 8. Red litmus, these things change color at the same pH of 7. We know magnesium is a common metal that we like to use. It'll fizz away in strong acid solutions. And p-hydrogen paper can give us a more precise pH than an individual indicator. So that's your opening notes, and with some strange music that will put me in some kind of copyright violation. So those are things that we want you to be on top of.